Hello and welcome to another webinar by the AM Academy. Today we'll be looking at and comparing two different handheld 3D scanners, specifically the Shining 3D Einscan H and the Shining 3D Einscan HX. We'll be looking at what each one of them is good for, what you can use them for, and why you would want one or the other. So to begin with, I've got like a little bit of an overview. So we'll be starting with the Einscan H, and then later on we'll be looking at the Einscan HX. So starting off with the Einscan H, you can see it's the tiny little handheld thing, fits well into your hand. It's about 700 grams in weight, so not very heavy at all. And it's got all these little windows here. And as you can see behind me, and I'm going to make that big for a second, you can see that it has two different cameras, one at the top, one at the bottom, and two different light sources. At the top, there's an infrared light source, and at the bottom, there is a structured light projector. And that's what is basically the key component of this handheld scanner. It is a hybrid scanner that can use both invisible infrared light or visible structured light from an LED projector. It also has a color camera, so it is able to capture the color and surface texture of your object. Then on the back of the scanner, you can see up there in the other image, you have a couple of buttons. There's a start, pause, stop button to control the scan while you're scanning. There's also a zoom button, zoom in and out, and a brightness up or down button. This lets you manipulate your scanning without having to go back to the computer every time you want to change a tiny little thing. Now, why is it so important that you have both the invisible infrared and the visible structured light? Well, that's actually because of the purpose for which you could use the scanner. This scanner, and I'm going to turn off my camera here real quick so you can have the entire table on the screen, has three different scan modes: a standard scan, a body scan, and a face scan. And as you can see under not the column, but the line light source, both the standard and the body scan use the visible structured LED light. But the face scan, which is perfect when you want to scan a human face or a body, including hair, that's where the invisible infrared is used. And you can see that the accuracy is considerably lower, but it's way better at scanning faces and hair without blinding the person that you're scanning. So if you scan using visible LED light, it'll be very bright. The person that you're scanning will just be, blinded and potentially have, lasting damage or is very uncomfortable. But the invisible infrared light is perfectly suited to scanning a human face or hair. But that's not what we're going to do today because it's difficult to scan my own face. Instead, I'm going to take my USB cable and just plug in the scanner. The USB cables that are included with the Shining 3D scanners are 4.5 meters long, so they give you plenty of room to move around. And now, on the back, the lights turn on. I'll wait for the computer to realize there's the little ding-a-ling that a USB device has been connected, and now I can switch to the scan software and click the refresh button because now I have connected a device. And what we'll be doing first now is I've brought a shoe, and I want to scan this shoe, but I don't just want a standard model of it. I want it including all the colors and surfaces. And this shoe is, for that purpose, ideally suited because it has a lot of differently colored areas where it's very easy to see, well, the difference between texture 1 and texture 2. And it has these little fake leather patches on the side that are slightly reflective. And with an area that is white and an area that is dark but reflective, we'll have to play around with the brightness setting of the scanner during the scan in order to capture everything properly. So that's why I chose this model. It illustrates some of the difficulties or some of the things you might have to do when scanning your objects. I'm not going to be doing the body scan or the face scan today. If you are interested in the body scan, we have done a video in the past where we scanned an arm and then created an orthesis, so a wrist brace basically, from that scan to then 3D print it out of polypropylene. If you're interested in that, check out that video on our channel. For now, though, as I said, I'm going to go for the standard scan option. I'm going to make the scan software big again so you can really see what is happening. Of course, whenever you use a scanner for the first time, you would have to calibrate it. I did that yesterday, so that's not going to be necessary today. I'm going to create a new project group in my test folder. I'm just going to overwrite the test folder, as I always do. And now you can see I have the option to select a texture scan or a non-texture scan. And I do want a texture scan. I want to scan, well, the model with all its colors, with all its surfaces. Then I have different alignment modes. I could use markers. Markers are not very well suited to what I'm doing right now. I could use features, which is quite interesting. There's a hybrid alignment between features and markers, or because I'm scanning with texture, I can do the texture alignment. And I'll want to try this for now. The resolution. Quick word about this. Resolution does not equal accuracy. So the accuracy stays the same, but what the resolution is, it's the distance between any 2 points in your point cloud. So you want to change this depending on the size and purpose of your model. If you're scanning something where you really need a very detailed point cloud with extremely small features, well, you might want to go for a higher resolution. For something like the shoe, where there's nothing that is less than, I don't know, 0.5 millimeter in diameter, 1 millimeter is totally sufficient. I'm going to stick with medium detail. The higher you set this setting, the longer your scan time will be, the bigger your file will be, the longer it'll take to generate a mesh out of it, and you will have an overall worse experience the higher you set the setting. But of course, if that's what you need, you have to adjust this. So it doesn't make sense to just scan every model at the highest detail. So medium is entirely sufficient for me. We're going to start this project, and now I'm going to take my scanner, and you can see in the top left, there's a little preview window of what the scanner sees. It already sees my shoe right here, and then I'm going to press the play button on the back of the scanner, and it'll start a preview of my scan. So you can see that's already where my shoe is, and using the brightness button on the back of the scanner, I can adjust the brightness a little bit. And you can see that in this preview window, if I have the brightness very high, I have a lot of red areas. Red is overexposed. That's not what you want to do. So I lower the brightness a little bit. Just about here sounds fine. It seems fine. And then I'm going to start scanning. And we'll see how well this works now. It's always a bit interesting to do these things live, where you're not sure how well the result will work. But it looks like it works quite well. This turntable here is quite nice, so I don't have to walk in front of the camera. Instead, I can just stand here and rotate it slowly once in a circle, letting me pick up the entirety of the model. So just like that. So now I'm gone around once. I'll tilt the scanner and really try and get everything here, all the different areas. There we go. Once more for the other side as well. Capture everything. And then we can have a first look at what this has done. So I just press the pause button on the back again. It'll stop scanning for the time being. And now I can see it's actually picked up most of my leather right here. It didn't do that yesterday, so I must have adjusted the brightness a bit better. Especially down here, there's still a hole. So what I can do is I'll start again, and then I'll turn the brightness up high to the point where, oh, come on, it has to align properly. And it really doesn't want to. It's not finding its alignment right now. I don't want to start scanning and overwrite what we did before, but I guess I'll just do that, see whether it really... There we go, now it's aligned. And now I'll turn up the brightness so the white areas are completely overexposed, but as you can see, the darker areas of the shoe are still being picked up. And now if I rotate, this will be much, much better to actually pick up these dark and reflective areas. Does mean that the tracking is considerably more difficult because it can't see the white areas. So the scanner is wondering where its tracking it went, but that looks good. And that way I could pick up a bit more of this leather side. Now, of course, I do have some areas that I scanned that I don't want. So using Shift and the mouse, I could, just select all of this and then delete it. And then, move on. I could do this a bit more detailed if I really wanted to, but for the purpose of this demonstration, I think this is totally fine. And I'm going to let it generate a point cloud out of this and then do an unwatertight mesh. So I don't want to fill the holes. Now, of course, if I wanted more details, if I wanted the sole of the shoe as well, I could still do that. I could, continue scanning this model in different orientations. I could put it down this way, I could put it down this way, really pick up all the different areas of my shoe and get into every nook and cranny depending on how detailed I need my model to be. But I think for the purpose of the demonstration, this is already fine. It shows how well the texture is actually picked up by the scanner. And as I said, the accuracy is still very, very good. I hope I'm not too choppy while the software is calculating. That is always, of course, the difficulty. And now this is the point cloud, which actually looks pretty good. So I'm going to make a mesh out of that. And I want an unwatertight model. And I think it's fairly obvious how you can use this for prototyping, for a variety of applications where this type of scanning can be very, very useful, where you do need to pick up the colors, where you do just want to have a quick scan. And the Einscan H is fairly cheap compared to the Einscan HX or other, I'll call them higher class solutions, such as the FreeScan UE or something like that. So we can have a look now, and you can really just see how nice this slightly reflective fake leather is. Everything else looks good. Obviously, I have a lot of holes in here, as I said. If I wanted this model to be complete, I would have to rotate the shoe. I would have to do a bit more work. But you can even see the structure of this mesh type thing right there. You can see how dirty the shoes are. So it picks up just about everything. The writing on the side is quite legible and clear. So the result is really quite surprising and very, very good using this scanner. Now, of course, as I mentioned, the scanner is also specifically designed to be able to scan body parts or even face and hair. So if that's something that you want to do, the Einscan H is specifically what you would look for. Now, where does the Einscan H struggle? Well, it's as soon as anything becomes black or very reflective. Let me get rid of my table over here and get a slightly different part into the equation. I'll have my little table here. And now I've got this, I don't know, not an AC because it doesn't actually cool a lot, but it's a ventilator. And you can see that it has this black and shiny plastic front. And now if I want to scan this with the Einscan H, I'm going to have significant difficulties actually getting a good result from that. So I'm going to go back because I don't need my shoe model any longer. And I'm just going to start another standard scan here and just show how much it struggles with this area. So scan initializing is taking a bit. New group, overwrite my test folder. Yes. And now this time I don't need the textures. I'll just do a feature alignment. Everything like that is fine. Just click apply. And now I can start scanning my thing. And I need to reduce the brightness a bit. And as I scan this now, first you can see that the non-texture scan is a bit faster than the texture scan we did a moment ago. But you can see there's no way I can pick up any of the black and shiny areas. Everything else is fine. Everything that's white is absolutely no issue. But the black and shiny stuff just isn't there. And no matter what I would do with this one, no matter how much I would turn up the brightness or anything like that, it won't fix this issue. So what else can we do? Well, I could use a scanning spray. Basically liquid chalk. I could spray all of this white. Then it is white, then my scanner can pick it up. Or what I can also do, now I want to keep this one, but I wanted to put the scanner aside. I can unplug the Einscan H, put it over here, and instead plug in the Einscan HX. Now, what is the Einscan HX? Well, Einscan HX is also a hybrid 3D scanner, also handheld, also about 700 grams, but there's a key difference. Instead of infrared light at the top, there is now a laser. It's a blue light laser, and it can project 14 laser lines, so you have 7 blue light laser crosses, if I have it correct in my head. We'll see in a minute. And these blue light laser lines are way, way better than the structured LED light at picking up black or reflective surfaces. Also, it is considerably more accurate. So first I will make this big for just a second so you can see how this one is set up. And I think it's obvious how, yeah, it's basically the same scanner just with slightly different setup, considering there's no infrared and instead now there's laser light. Then, of course, you're looking at the 2 modes. So no longer there are 3 modes, but there are 2 modes. There's laser scan and rapid scan when using the Einscan HX. And the light source obviously changes between the laser light and the LED light. You can see that the accuracy is even higher using the blue light lasers, and the resolution can be turned up to the absolute maximum. Disadvantage of the laser scanners, of course, there has to be a caveat. You can only align via markers, which is why, if you already looked at this, I have a bunch of markers plastered all over this ventilator just to demonstrate the difference. And it's a bit slower, so it can only pick up about 480,000 points per second, as opposed to the over 1 million points per second that the rapid scan mode can do. What is rapid scan? Well, it's basically the same as the standard scan mode of the Einscan H. So don't think that just because you're getting this one, you have to give up the functionality of the other one. The only thing this one cannot do is scan faces. Definitely do not try to use the laser scan to scan any human or face, because that can actually lead to eye damage. Instead, this one is perfectly suited to scan any old model, so I could use this one to scan my shoe as well. It's a bit overqualified almost for that. And I need to start the different scan software, because obviously the Einscan H software is no longer suited. No. Come on. Where's the... There it is. So it'll start the software now, and then I can actually use the scanner once again. First time use, should be calibrated. I've already done that. But we can just get right into this one now. So there's a higher accuracy using the blue light laser. You also have the visible LED light for any normal objects that are not reflective or that are, you know, the same as my shoe. Because one more difference between the two, and that was visible at the very bottom here, is that the blue light laser scan is not capable of picking up textures. So if you want a texture scan, you have to go for the rapid mode. So, and now, as you should be able to see, there are 2 different scan modes using the Einscan HX. There's a rapid scan and a laser scan. Now, the rapid scan is just about the same thing we had before. It uses the structured LED light. You can align via markers or via features. It can have the texture scan, so you can pick up the surface of your part. I could do the shoe again, basically, now, if I really wanted to. I'll just get into the menu real quick, so I can show all these different options right here. So I can have the texture scan, align by texture, or hybrid, or markers, whatever I want. I can have a considerably higher detail than before if I really want to. But as I mentioned, especially for a model like this, there's no point setting the resolution to 0.05 millimeters or something like that. That is just ridiculous. It'll result in a bad scanning experience and not yield any additional use. So instead, you know, I would do a non-texture scan, scan this thing using the visible LED light. I would have the same issue that I did with the Einscan H. I can't pick up the black and reflective surfaces. So instead, what we're going to do is we're actually not going to do a rapid scan because, well, we've already seen what that looks like. Instead, we're going to do a laser scan. So that's going to start up. New project group, overwrite my test folder. As per usual, yes, I really do want to overwrite it. And we can see that now my options are far more limited. And this is due to what I mentioned earlier. The laser scan can only align itself using markers. No more features, no more texture, all of that is gone. So all I have left as a selection is to determine my resolution. And for this kind of model here, my medium detail will be entirely sufficient. It'll keep the calculation times down as well. So now my mouse is acting up again. There we go. Okay, so we're ready, and you can see how the menu on the left-hand side is now a bit more verbose. There are more options. You can either scan the point cloud, you could scan only markers. If you have very large parts and you want a high accuracy, I recommend first scanning only the markers and then scanning your point cloud afterwards. That can help, especially for a larger model. So if you scan an entire car, this is what you would want to do. For something like my model right here, it's not necessary. Then I have different selections: normal, reflective, and black. And that right there is what we're going to be using later on. They're basically presets for the brightness and data setting that you have down below. You can see how they change depending on which area I click on here. So starting off with normal, if I press my play button again, I'll have my preview, and now you can see how the blue light laser, you can see it in the preview window in the top left, how they're alternating, and in the preview they're just static, and you can see all these blue light laser lines with all those crosses that actually then pick up my model as soon as I start the scan now. And picking that up, obviously, it'll only fill out where the scan lines are. So what you want to do is kind of like wiggle the scanner around a bit. And you can see how all my markers help it orient. It picks up all these little silver dots. But you can see that this one as well, right now, is having some difficulty with the black areas. It picked some of it up, but not all. So what if I set it to reflective and then just start scanning once again? It's already picked it up. And now, if I just go back and forth a bit, voila, we actually have a proper scan, including the areas that were exceedingly difficult to pick up before. So that right there is the big advantage of the blue light laser scan. It can get black surfaces, it can get reflective surfaces, eliminating the need for scanning spray, at least for models like this. If you have something, I don't know, chrome or something like that, that is really just a mirror or glass. That's something where even the Einscan HX will struggle. But as long as it's, you know, not glass and not a mirror, everything should be totally fine. Great. So that's basically the base level comparison between these two scanners. Infrared and visible LED light for the Einscan H, laser light and visible LED light for the HX. Each one of them has some things the other cannot do. This one is well suited for scanning face and hair. This one is suited for scanning black or reflective surfaces. So if, I don't know, you're scanning humans a lot, you want to do orthesis for wrists, knees, whatever, Einscan H is your best friend. If you're more into, I don't know, quality assurance in manufacturing, well, you might want to have a look at the Einscan HX. There is obviously a price difference between the two. The HX is considerably more expensive just because the laser light is so much more, well, trying to think of the English word, I only have the German one right now, anspruchsvoll, so it just requires a lot more. And then, of course, the accuracy is a bit higher as well. But for everyday needs, for just scanning a model, like my shoe, like, you know, anything else that might be around, the Einscan H is probably already a very good value proposition. So I don't see any other questions in the chat right now. So I think, well, that's all I have for you today. Thank you very much for watching. If you did like this webinar and would see more like them in the future, hopefully without any tech issues, hopefully without any screen glitches or whatever, then do subscribe to the channel. We do these every 2 weeks. where we try to keep up the schedule anyway. At some point I'll have a vacation and we'll skip one. But in general, we try to do this. We also upload other videos about 3D printing, 3D scanning, anything like this. So if you're interested in that, please do subscribe, come by. And if you have any feedback, questions, comments, please leave them below the video. Thank you very much for watching, and I hope to see you next time. Yeah, have a great day.